This is Derek Sites. This video presents a set of algorithms pseudocode guidelines. These pseudocode guidelines are designed to promote clarity, consistency, and simplicity. And using these guidelines will prepare you to write real programming language code. As in any code, you have to make the decision of whether it's going to be very English-like free form or more highly structured coding form. For clarity, it's necessary that it move more away from free-form English and more towards precision. Otherwise, we're inviting ambiguity in our descriptions. However, to keep things simple, we want to avoid cumbersome syntax. These guidelines are positioned at a good point in this spectrum between free-form English and precise syntax. As in any syntactical entity, there are some reserved words. This pseudocode language has the following reserved words, and they're grouped by similarity. They will be appearing in pseudocode in all lowercase to keep things simple for typing. First, the arithmetic operations: add, subtract, multiply, and divide. The logical operations: and or. Conditional constructs: if and else. Input and output: get and print. Repetition constructs: repeat and while. These are flow controls: the repeat and while and the if and else. Set is an assignment statement to change the value or initialize the value of a variable. Stop ends the algorithm. And true and false are Boolean literals. Reserved symbols: a hash sign begins a single line comment. Plus addition, minus subtraction, an asterisk for multiplication, / divide, the hat symbol for exponent, less than for less than, equal to, less than or equal to, greater than or equal to. A double equal sign is used for equal to comparisons. In programming languages, a single equal sign is used for assignment statements. These guidelines will use the set statement, leaning a little more towards English-like syntax, and the double equal sign for comparison, for equality. An exclamation equal means not equal to, and parentheses can be used to group expressions, to change the order of operations as necessary in mathematical calculations. Comments. You start a comment with this # character or hash character. Everything from that character to the end of the current line is a comment, not part of the executing algorithm. Literals are fixed values. Do not put quotes around number literals. Put double quotes around text literals. Use true and false for Boolean literals. Here's some examples. The number 144 as an integer, the decimal number 3.14, text, autumn leaves, surrounded by double quotes. And here we have a statement: set the variable is raining to true. True is a Boolean literal. Is raining is a Boolean variable. Variables. Variables represent locations in memory of a computing agent, computing device. In an algorithm, they represent things in the environment that can change. They use camel case with a leading lowercase letter. Camels have a hump in them. Look at these examples of variable names. Average temperature. Notice the first word in this variable name, average, is lowercase, and the other word is uppercase. There are no spaces in variable names. This is called camel case. Wash count. It's another example. Number of times something is washed. For a list, we can use index notation. A list is a set of similar items that you want to treat as a set or a group or a collection. And to do that, you use an index to refer to which item in the list is needing to be referred to for an operation. Indexes in real programming languages are usually zero relative. However, in this algorithmic pseudocode, they can be zero relative or one relative. Here are some examples. These variable names here, t0, t1, all the way through tn-1, would indicate a zero relative list using these kinds of names for variables because the index suffix starts with 0. Ti represents the ith t value, and it's used with an index I. So if I is 5, we're referring to the variable t5. If I is 0, we're referring to the variable t0. This is a zero relative list of variables. Here's another list, a one relative list. Each of the items is referred to with the name text, and the suffix indicates its position in the list. Text 1, text 2, text n. Notice the 1 for the first item as opposed to the 0 here makes this a one relative list. And to refer to a given item in this list, we would use text I, where this represents the ith text value, and you would have to have a separate index variable I set to a particular value in order to refer to text I. For example, if I was 5, then text I would mean text 5. Values of variables. A variable's name represents its value. Writing the value of is not required. Example. Either one of the following two styles is okay. Set the value of count to 0. Count is a variable. You can say set the value of count to 0, or more simply, say set count to 0, because count itself represents its value. Statements. Do not put multiple statements on the same line. Do not use any punctuation to end a statement. Do not use step numbers. Instead, indentation will be used to group blocks of statements together for the different flow control scopes. Input and output statements. Get the values of A and B from the user. Simply say get A, get B. To compute their sum, so this is an input processing output pattern here. Set sum, that's a variable, to A plus B, and then display the value of sum for the user, print sum. Here is a fancier formatted version. You can say print and then a comma separated list including string literals and variable names. Here print the sum of space, the value of A, space and space, the value of B, space is space, the value of sum. Conditional statements. Example, if there was an error, print there was an error. Notice that the block is indented under the if statement. It can consist of one or more statements at the same indentation level. And this block is only executed if this condition, there was an error, evaluates to true. The second example is an if with an else clause. If there was an error, print there was an error. Else, print processing is complete. The indentation for this first block associates it with the if. The indentation of the second single statement block associates it with the else. One or the other of these statements will be executed by the algorithm, depending on whether or not there was an error. Another example, this uses a logical and with some relational test. If score is greater than or equal to 70 and the score is less than 80, set the variable letter grade to the literal text literal C. Statement groups, also known as blocks, do not refer to step numbers to refer to a group of statements. Instead, use indentation. Indicate a block by indentation. Use at least 2 spaces for each indentation level. In these guidelines, 2 spaces are used for each indentation level. Example, determine and output the sum of a set of numbers. Set total to 0. Total is a variable. It's initialized to 0. Get next number. This gets next number from the environment, from the user typing it in at the keyboard or from a file or however it's determined to get it. And then we have a loop while next number was obtained. Add next number to total and get next number. This will be repeated each time, checking whether a next number was obtained. When the complete set of numbers has been processed, the next number will not have been obtained, and the block here will be skipped, and the total will be printed. So notice the flow. Sequential flow, and then looping, and then back to sequential. Computation. Some examples. You can add a literal or a variable to a variable. You can subtract a literal or a variable from a variable. You can set a variable to an arithmetic expression. Examples. Add 1 to counter. Counter is the variable. Add interest to account. 2 variables here, an account and an interest. It takes the value of interest and adds it to the value of account, producing the new value in account. Subtract 1 from persons in line, changing the value in persons in line by decreasing it by 1. Set average, the variable average, to sum divided by count. Set sum to this arithmetic expression here, n times n plus 1 divided by 2. In all these set statements, the target, the variable that is being changed, is introduced here, if it has not already been introduced in the algorithm, just by its presence in the statement. List indexing. We mentioned list items previously in these guidelines. Use a variable with an index suffix to refer to a list item. For example, if you have items in a list with variable names, item 1, item 2 through item n, you use item I to refer to its ith item, and you would need a variable I in order to resolve which item you're talking about. Here are some looping examples. First example, get n, set sum to 0, set number to 1. While number is less than or equal to n, add number to sum, add 1 to number. Keep looping here, adding 1 to number every time until it's no longer true that number is less than or equal to n. And then finally, print the sum of the first n numbers is sum. Another example using a repeat, get n, set sum to 0, set number to 1, repeat n times, add number to sum, add 1 to number. After exactly n times of running this loop, print the sum of the first n numbers is sum. Notice that all of these algorithm pseudocodes are general. Depending on the input, they produce different values, different calculations, but they follow the same process every time. Another example, this one uses a list with index notation. Get n, that's the number of items in the list, get the individual items, item 1, item 2, all the way through item n. That initializes the list. Set I, which is being used here as the index, as the suffix index, to 1. So it'll be a 1 relative list, as we see by the names of the variables. While I is less than or equal to n, the number of items in the list, print item I, add 1 to I. This will print each of the items in the list on a separate line, each one. The I here is serving as an index suffix based on its current value. It refers to a particular item in the list. To stop, flow automatically stops after the last step from a top-down sequencing in an algorithm. To stop before the last step, use a stop statement. Example, determine and output whether a number is positive or negative. Get number. If number equals 0, print neither positive nor negative and stop. Otherwise, if it's not 0, you continue. If number is greater than 0, print positive, else print negative. So here this stop statement would end the algorithm, and these other statements would never be considered. So this completes the presentation of these algorithm pseudocode guidelines.